Okay, representing aqueous reactions. Just like there are different types of chemical formulas, there are different types of chemical equations. The molecular equation is kind of the regular type of chemical equation. It shows the complete neutral formulas for all of the compounds in the reaction as if they existed as molecules. So this is a sort of equation we've been writing, something like this. But what's actually occurring when this happens? Potassium hydroxide is soluble. It's an ionic compound. When an ionic compound dissolves, the ions separate. And so this doesn't really reflect what potassium and hydroxide are doing. They're not going around at this party holding hands. They're walking around separately. And so in a complete ionic equation, we show all the species as they're actually present. So we'd show potassium as an ion and hydroxide as an ion separately, and magnesium and nitrate separately as our reactants. In the products, the first one is a soluble ionic compound, so potassium ions and nitrate ions, but this is a solid. What this is actually doing in that beaker is it's clumped together on the bottom of the beaker. The magnesium and the hydroxide ions are together, and so we leave that alone. So that's what happens with a complete ionic equation. The net ionic equation only shows the species that actually change. So in that previous example, this one, so sodium and hydroxide, let's look at these guys. Sodium and hydroxide and copper and bromide go to a party, right? And copper and hydroxide hit it off and they're making out on the back porch. Did anything really happen to sodium and bromide? No, they're still just at the party. They are unchanged. So the net ionic equation, we don't include those. They weren't part of the reaction. They're just hanging around. So we call them spectators. So writing a complete ionic equation, you're going to write all of the aqueous ionic compounds as ions. These are the soluble salts, the strong acids, the strong bases, anything that's a strong electrolyte. If you see AQ as the state symbol, solids, liquids, and gases, those are all written as molecules because they're not ions in solution. These are the weak electrolytes, the non-electrolytes. The weak acids, the difference between a weak acid and a strong acid is a weak acid only ionizes a little bit, and a strong acid ionizes completely. So because weak acids only do it a little, we're going to write what they mostly are, which is the intact molecules. So in this equation, here's the molecular equation. To write the complete ionic equation, we're going to take this as a soluble ionic compound. There's one lead-2 ion and 2 nitrate ions. So we're going to write them separately because they're floating around separately. KCl, there are 2 potassium ions because there's 2 of these units, and 2 chloride ions. And then in the products, the PbCl2 is a solid, so we just copy it down, don't change it. And KNO3 is aqueous, so we write the individual ions. Any questions? I have a question. What the heck is that? I don't know. Oh, I think I know. We'll look at it later. In the net ionic equation, you take your complete ionic equation and you look for ions that aren't changed. So we had 2 nitrate ions here, and we still have 2 nitrate ions floating around. Those are spectators. They're watching. So we cross those out. Cross them out. And then potassium's just hanging around watching too. So the net ionic equation is like your net paycheck, where they take out money for taxes and all the other stuff, right? And you get less. I saw my overload check, and I'm like, how does that even happen? It was the total was like $400. This is just for the extra class I'm teaching. It was like $400, and my net was $53.29. $53. What the heck? Anyway, just a little peeved about that one. So this just shows us what's actually changing. The other ions are there, but they're not changing. Any questions? Let's practice. Okay, so consider the following reaction. Write the complete and net ionic equations. So here we have, what kind of a compound is that? Starts with H. It's an acid. This is an acid. So it will ionize, but we need to know, is this a strong acid or a weak acid? And the book mysteriously has not said yet. So let's look ahead. There they are. Hydroiodic acid. So these are the strong acids. There are 6 of them. There are 6 strong acids. You just have to memorize them. So more flashcards. Yeah. The ones in red are weak acids. There are lots of other weak acids. The way you do this is those 6 are strong acids. Every other acid is a weak acid. So HI is on that list. So this is a strong acid. So we're going to separate that into ions, and we're going to separate that one into ions. How about H2O? No, because the subscript L, it's a liquid. L for leave it alone. And this one's aqueous, an ionic compound. So if it's aqueous, most of the time, it's going to get separated into ions. The only exception is weak acids. So I'm going to take that 2HI. The ions there are H plus and I minus. I minus ran into the I. There we go. The coefficient 2 in front is saying I have 2 moles of that substance. So then I'm going to get 2 moles of hydrogen ions and 2 moles of iodide ions. The next one, barium hydroxide. The 2 ions are barium ion and hydroxide ion. Did you know that helium, curium, and barium are medical elements? If you can't helium or curium, you barium.
Oh, that was so painful looking at it.
Okay, so here in BaOH2, there's 2 hydroxides. So we need to put 2 here. And I'm really, really hating how the screen is lagging so far behind what I'm doing on my iPad. Okay. So those are our reactants. And then we look at the products. Liquid, leave it alone. Just copy it down. 2H2O, L as the state symbol. And then another aqueous. We've got Ba, 2 plus, aqueous. And there's 2 iodide ions, 2I minus aqueous. In the molecular equation, there are no charges of ions listed because we're writing the neutral formulas for the compound. In the complete ionic equation, it's an ionic equation. It has separate ions. The ions have to have their correct charges. That's the complete ionic. The net ionic, we cross out the spectators. Who are the spectators? Ba2 plus and I minus. And then you just copy down what's left. So I've got 2H plus aqueous plus 2OH minus aqueous forms 2 H2O, liquid. What's weird about that? Is that the best balanced chemical equation we could write there? We could reduce all those 2's, right? It's 2 to 2 to 2. In the balanced chemical equation, we want the lowest ratio of coefficients. So we should really get rid of the 2's. I won't try to trick you on something like that, but I can't speak for mastering chemistry. Any questions? Yeah.
Are all acids aqueous?
All the acids we're going to see are going to be aqueous. Yeah. Because technically, if they're not aqueous, then they're a molecular compound. Yeah. They will form ions, but most of them will only form a little bit, and so that's why we don't separate them into ions. Any other questions?